Welcome to our second video that has to do with evaluating logs. I want to pick up a few of the things that maybe you hadn't thought about. Actually, I'm going to move this right here. I want to look at something like this. This right here is problematic for some people. They don't know what you'd raise 4 to land right on 0.25. They don't know what power it would take to make that land on this. However, one good rule of thumb is that when you're evaluating logs, decimals are not your friend. So if you write that as 25/100ths and reduce it or use a calculator and change it over to a fraction, now all of a sudden it's not that hard to evaluate. What power do I raise 4 to land on 1/4? Well, I don't know. What power would I raise 4 to that makes it come underneath the 1? If you remember right, again, the negative exponents. When you raise things to the -1 power, 4 to the -1, it ends up being equal to 1 over the same base to the +1, and there's your 1/4. So basically, it became less complicated when I took the decimal and I rewrote it as a fraction instead. I want to look at a couple of other things. Let's look at this one right here. 2 to some power gives me 9. 2 to the some power is equal to 9. So I'm looking for the exponent that makes 2 land right on 9. Well, 2 squared would only be 4. 2 to the 3rd would be 8. Still not quite big enough. 2 to the 4th is 16. Now I'm too big. So this number will not always be a nice little integer. It doesn't mean there isn't a number out there. We know it's bigger than 2 to the 3rd. We know it's smaller than 2 to the 4th. So it's probably 2 to the 3 point something. Right now, we cannot evaluate this thing here by hand. We will learn a formula later that will allow us to evaluate things like that. But not all logarithms can be evaluated in your head or even on a calculator. However, this log of 17, do you remember what the base is every time one is not written? We learned that in the other video, the first video. Every time you see log written and you don't see a base written, it's implied to be a base 10. So is there some power out there that I would raise 10 to land right on 17? Well, 10 to the 1st, 1 is not big enough. 10 squared, wow, that's way too big, that's 100. So it's somewhere between a 1 and a 2. So it's 1 point something. Your calculator, however, can evaluate that because it has a key that says log right on it if you have a scientific calculator. And if you go log and then 17, it will tell you what number that you would raise 10 to land right on 17. So there are certain kinds of logs, of which logs to base 10 are one of them, that would tell you what you would raise 10 to land right on a number. Okay. I think the only other thing I wanted to cover, if you want to take a screenshot of this, I'll wait a second. Okay. Again, you don't need to take screenshots of the board, but it's kind of a form of preserving notes before I erase them. Okay. So with that in mind, I want to look at just one more logarithm that I haven't shown you yet. Ln, that's not in, it's Ln. And that's actually shorthand for a logarithm of one particular type. When you see Ln 5, again, no base is written but because it's not the word log spelled out, we know it's not base 10. The meaning of this symbol is L-O-G, little e, and 5. Now you might wonder what this e stuff is. Well, just like pi is a strange little number that goes on forever and never stops, and then it keeps on going, but it never has a repeating block. It's one of those values that comes out of geometry, looking at how the diameter compares to the circumference of a circle. This is like pi in that it also never repeats any digits. The digits will never stop. And the reason we use symbols like this in life is because it's inconvenient to try to write a number that goes on forever and ever. So we write it really as a matter of convenience. This is a number that comes out of natural sciences and also some financial things. So when we see an E, that's called a natural log. So again, this is used an awful lot in the science fields because it arises in biology and in different formulas that you see if you're working in those fields. But when you see ln, just that part of the symbol means all of this. So if ever that confuses you, you would be able to expand it like that and clarify things. Now, as far as what power I would raise that yucky number to land right on 5, I don't know. This is not one I would be expected to evaluate by just thinking about it. Okay, so it is one, however, that your calculator is set up to do. Just like there's a log to base 10 key, L-O-G, on your scientific calculator, there is an ln key. You probably thought it was saying in, but there is a natural log key on your calculator that can evaluate these kinds of logs. Okay, so just let's look at a couple of natural logs that I can evaluate. This means L-O-G, little e of e. What power do I raise e to land on itself? Well, what power do I raise 7 to land on 7? That was one of the properties we discovered during the first video. Anytime the base and the argument match, the exponent is going to be a 1. So that property is still true. If you get confused with this notation, rewrite this portion of it. This is the argument, so you just carry that down. And here's one last log you can do. If I have log written ln, and I have 1 here, that's a 1, not an L. Okay, what this means is L-O-G, little e, 1. What power do I raise e to get a 1? What power do I raise a 3 to get a 1? What power do I raise a 10 to get a 1? What power do I raise 2 to get a 1? Do you remember the property we learned last video that said the log to any base whatsoever of 1 is always 0, since anything to the 0 comes out to be 1. So again, that right here, ln of 1, would equal 0 for the same reason as the rule we had the other day. That concludes video 2 on logarithms.